Okay, guys, today we're going to look at lesson 9.5. And it's 9.5 because I realized later, after I'd already made the homework, that I missed a section. So instead of messing everything up and renaming everything, I'm just making this one lesson 9.5. So it's between lesson 9 and lesson 10. This is coming out of section 2.2 in your textbook, and your learning objective is I can identify and write equations of direct variation. Now, as usual, you should have your notebooks. You should be ready to take notes, do examples, and answer the Edpuzzle questions. And remember, I am going to go faster in the video than I would if we were in person, because you have the ability to pause and not fast forward, but you have the ability to pause and rewind as you need to throughout the notes. Also, there's nobody here for me to talk to and to answer my questions. So it's really hard to take the same amount of time as we would if you guys were here to respond to me. So just keep that in mind. So we're going to start with our vocabulary. As usual, we just have one term today. So our only term is direct variation, and that's a relationship that can be represented by a function in the form y equals k times x. So this is just a specific type of relationship or a specific type of function. It means that you get y by multiplying x by a constant, and a constant is just a number. It'll look like the coefficient. We call k the constant of variation. So that is how x is related to y. It's being multiplied by k. Now, with direct variation, we're going to do a variety of different problems. The first type is going to ask you if the function is direct variation, and if so, what's k? Now, in Math Excel, it's probably going to have this worded a little bit differently, but you're still going to be doing the same thing. You're going to decide if the function is direct variation, and if it is, you just have to say what k equals. Okay, we'll start with three pretty easy examples. So if we look at number 1, we have y equals 3x. Is that function in the form of direct variation? It's supposed to be y equals some constant times x. Do we have y equals a constant times x? Yes. So we'll say, yes, that's direct variation, and we have to know what k equals. So k is that constant in front of x. So on that one, k equals 3. Okay, take a look at number 2. Is number 2 direct variation? Does it look like our example function? No. We're supposed to have a number times x, but here we have x minus a number. Does this say anything about addition or subtraction? No. So there, your answer is just going to be no. And if it's no, we can't find k. Now, number 3 is just a little bit different. For it to be direct variation, the y has to be all by itself. So we need to get y all by itself. How can I do that? We can divide by 3. And if we do it to one side, we do it to the other side. So that's y equals. Now, we have y equals x over 3, and that's the same as y equals 1/3 x. Now, is this direct variation? Does it match our form? Yes, it does. So our answer is yes. And what is k? 1/3. Our next 3 examples are a little bit different because y isn't by itself. So we're going to have to rewrite these equations and then decide if it's direct variation or not. So I'm going to work out number 4 with you. All right, so we want to get y all by itself. So if we were solving this just as a regular 2-step, if the x was gone, what would we do first? We would add 4. So we're going to do the same, but we're just going to tag the x along. So we have 3y equals, now 0 plus 4x is just 4x, right? Now we have 3y. How do we get rid of that 3? We divide, and we have y equals 4/3 x. So is that direct variation? Yes. And k equals what? 4/3. Okay, now number 5 is set up almost identical to number 4. So take just a second, give number 5 and number 6 a try. Pause the video, see what you can do on your own. Okay, let's check them together. Number 5, we want to get y by itself, so let's think about it like a two-step equation. How can I get that 8 to the other side? Well, add it. So we get 2y equals 8x. Now how do I get that y by itself? Divide by 2, and you get y equals 4x, because 8 divided by 2 is 4. Is that direct variation? Yes. And what does k equal? 4. All right, number 6, we've got to get the y by itself, so we need to move this negative 6x over. How can I do that? By adding 6x. So we get y equals 6x. Is that direct variation? Yes, it is. And what does k equal? 6. Okay, the next type of problem is a little bit different. You're going to be given a table of values, and you're going to have to decide if y varies directly with x, and if so, find k and write the function rule. So this is a little bit different. We're going to look for a pattern in the relationship between x and y, okay? So let's look at number 1. We'll do it together because it's a little bit more difficult. So we've got 51 and 17, 63 and 21, 66 and 22. And especially looking at those last two pairs, you might see a relationship, okay? So let's figure out. So if I'm going to come over here to the side, I'm going to do 17 divided by 51, and that gives me 1/3. Then I'm going to do 21 over 63, and that equals 1/3. And 22 over 66 also gives me 1/3. So that means that x times 1/3 will give me y. So those are all the same. So y is varying directly with x. All you have to do is multiply x by something to get y. So for our answer, we're going to say yes, it does vary directly. Our k is 1/3 because that's what we're multiplying by each time. And then your function rule is y equals 1/3 x. So there are 3 parts to that answer, but you can just do it step by step. Now that one's a little more difficult because you have that fraction. You're dividing, okay? But really, with direct variation, you have to have that number times x. So we know a fraction is the same as division. All right, so now let's look at number 2. And we're going to do the same thing. So 8 divided by 2 is 4. 10 divided by 4, oh, that just gives us another fraction, 5/2. And then 13 over 11, that's a fraction that doesn't simplify. Do you notice that your answers here are looking different than we saw here? Yeah. Y is not varying directly with x. We can't write a function rule that works for all 3 of these, okay? Because the first one, we got 4. But if we do 4 times 4, it's not 10. And 11 times 4 is not 13. So that's not varying directly. So we're just going to say no. And that's our final answer. Now, I want you to take a look at number 3. Give it a try. See what you can do. It should be easier than both of these, I think. So pause the video, give them a try. Okay, let's talk about it. So 4 divided by 1 is 4. 12 divided by 3 is 4. 32 divided by 8 is 4. So we're getting the same thing. You can multiply x by something and get y. So our answer is yes. What's our k value? 4, because that's what we're multiplying by. And our equation is y equals 4x. Okay, you have some problems very similar to this in your Math Excel work. Use these as examples, and you should be fine. Okay, our last type of problems are a little bit different. So it says, suppose y varies directly with x and y equals 6 when x equals negative 2. Find x when y equals 9. So this is one problem, okay? So like this is number 1. I should have numbered it. I put a box around these values because that's what's going to change from problem to problem, okay? And I'm not going to write down this sentence every single time we do an example. So I just want you to know that later when I tell you these numbers, this is where they go in the problem. And your ultimate goal is to find x, okay? So there's a couple different parts to these problems. And so let's look at how to work them out. So you are using the direct variation function form. So you are using y equals k times x. So you're given y equals 6 and x equals negative 2. So we're going to plug those values in. 6 equals k times negative 2. We need to know what k is. So what's the opposite of multiplication? Division. So let's divide both sides by negative 2. Not sure what I was trying to do there. All right, so those divide out, and we have negative 3 equals k. That's the first part of the problem. Now, I'm going to draw a little line so I don't get confused. Now, I'm going to use this y equals k times x again, and I know that k equals negative 3 and y equals 9. So now I'm going to plug these two numbers in here and get x. So y equals 9, k is negative 3, and we don't know what x is. If we have negative 3 times x, how do we undo that? We divide by negative 3, and we get x equals negative 3, and that is our final answer. So really, you're finding k, and then plugging k and your new y in to solve for x. All right, number 2, we're going to do the same thing. So this time, you're supposing y varies directly with x, and y is going to equal 10 when x equals negative 5. And you're going to find x when y equals 12. Okay, so instead of writing that sentence, I just picked out the pieces that we need, and we're going to do the exact same thing. So I'm going to use y equals k times x. I know y is 10. I don't know what k is, but I know that x is negative 5. How do I undo that multiplication? By dividing. And we have k equals negative 2. Okay. Now, I'm going to draw a little line because I'm going to do something very similar over here. Y equals k times x. This time, I know that y is 12. I know that k is negative 2, and I don't know what x is. So how do I get x by itself? We divide by negative 2, and we get x equals negative 6. And that's our final answer. Okay, number 3. Suppose y varies directly with x and y equals 8 when x equals -2. And then I want you to find x when y equals 24 or -24. Okay? Take just a second, pause the video, use examples 1 and 2 to see what you can do with example number 3. Okay, let's see how you did. So y equals k times x. We know y is 8. We don't know k. X is -2. We will divide both sides by -2 and get k equals -4. Draw your line. We're going to use y equals k times x again, where y is -24, k is -4, and we don't know x. What do I do to get x by itself? Divide by -4, and you get x equals +6. Okay, our very last example is a little bit different. It's very similar to examples 1 through 3, but this time we're given a context problem or a word problem. It's a real life application. So we're going to work through it. I don't think I wrote the word problem down exactly, but it gives you the main points. Okay, your problem in Math Excel will be exactly like this one, just with different numbers. Okay, so you should be able to follow it almost exactly. So we need to pick out some important information. We have $45. That's probably going to be important. And that's going to be our Y. Okay? And then we have our interest rate is 4%. We need to know what that is as a decimal. That's 0.04. And then we're wanting to find the interest, which is Y. When the rate is 5.5%, we need to know that is a decimal, so that's 0.055. Okay, so what we're going to do is we're going to set up our little y equals k times x equation or function. So we have $45 equals k times our interest rate, which is 0.04. So how do we solve for k? We divide by 0.04 on both sides, and we get 1,125 for k. All right, now we're going to draw our little line. We're going to do the same thing over here, but we're going to use some different numbers. This time we don't know what y is. That's what we're wanting to find. And we know that k is 1,125, and our interest rate is 0.055. You multiply those together, and you should get 61.875. We round to the nearest cent because it's money, so that's 61.88. So $61.88. Okay, you should be able to do the problem in Math Excel exactly like this. You're just plugging in different numbers. Okay, so you might have a different interest. You're going to have a different interest rate. You're going to have a different dollar value, but you should be able to work it out the exact same way that I did and get the correct answer. All right. As usual, if you need any help, make sure you let me know. Send me an email, hit that Ask My Instructor button, whatever you need, and have a great day.